right, for question 2, it shows you this reaction, okay? And it says a student designs an experiment to study the reaction between sodium bicarbonate and acetic acid. The reaction is represented above. The student places 2.24 grams of sodium bicarbonate in a flask and adds 60 mils of 0.875 molar acetic acid. The student observes the formation of bubbles and that the flask gets cooler as the reaction proceeds, meaning that it's an endothermic reaction, so keep that in mind. Identify the reaction represented above as acid-base, precipitation, or redox. So what I do is I notice acetic acid becomes acetate ions. HC2H3O2 becomes C2H3O2, which means because you have a proton being donated, that means that this is an acid-base reaction. So that's all you have to do. That's all you have to say. Because there's a proton being donated between the weak acid and HCO3 minus. Notice HCO3 minus actually becomes H2CO3, but then it breaks down into CO2 and H2O. So since you see proton being donated, it's going to be acid-base. So you got 1 point for acid-base and 1 point for correct justification. Next, it says, based on the information, identify the limiting reactant. Now, notice if you look at that reaction, you have a 1-to-1 ratio of your two reactants, which means whichever one has the fewest number of moles, that's going to be your limiting reactant. Because if I get into moles of each of my reactants and then get into moles of either product and then get into grams of either product, it's going to be the same thing. Whichever one has the smaller moles of reactant, that's going to be your limiting reactant in this case because it is a 1-to-1 ratio. So what I got to do is I've got to get into moles of each of them. Well, I've got 2.24 grams of one reactant, and then I have a volume and a concentration for my other. So I can figure out the moles for each of those, okay? Going from grams to moles for sodium bicarbonate and going from concentration multiplying by volume in order to get into moles of acetic acid, okay? So since I've got a 1-to-1 ratio, what that means is that NaHCO3, because I have fewer moles of that, that's going to be my limiting reactant. So you got 1 point for calculating moles of reactant and then 1 for identifying the limiting reactant. Okay. In C it says the student observes that the bubbling is rapid at the beginning and gradually slows down. Explain this change in the reaction rate in terms of collisions. Well, as the reaction proceeds, my reaction rate is going to decrease. We've seen that. And the reason why it decreases is because the concentration of your reactants decreases. So as your concentration of reactants decreases, that means the number of collisions is going to decrease, meaning that the reaction rate is going to slow down. Okay? So concentration of reactants decreases, which means that the number of collisions is going to decrease, which means your reaction rate is going to slow down. Okay? In thermodynamic terms, a reaction can be driven by either enthalpy, entropy, or both. Considering that the flask gets cooler, so remember it's endothermic, what drives a chemical reaction between these? Answer by drawing a circle. So we're wanting to use the formula delta G equals delta H minus T delta S for this problem. Okay? So for this problem, we know that this is endothermic, which means your delta H is positive, which doesn't help making delta G negative, which is our ultimate goal. So the only thing that could help could potentially be your entropy. And if you look at your reaction, notice you're going, if you look at the very beginning of the problem, you're going from a solid and an aqueous substance into an aqueous liquid and a gas. So your entropy is increasing, meaning your delta S is positive. Okay? And if we look at the formula, delta G needs to be negative, delta H isn't helping, delta S is positive, so if you're looking at delta G equals delta H minus T delta S, your entropy is actually what's helping your delta G be negative. Delta H is not at all because it is positive. So the way that I just explained that, that's what it's asking for in this problem. So let's look at that formula one last time. Since delta H is positive and delta S is positive, entropy is what drives your delta G to be negative since delta H is positive. All right? In E, it tells you that HCO3 minus has 3 carbon to oxygen bonds. 2 have the same length and 1 is longer. So that immediately tells me, since I have 2 that are the same length, that tells me either 2 of them have a double bond or more likely I have a case of resonance. Okay? And so if you look at the way that this is drawn, okay, I've got the bottom 2 carbon-oxygen bonds that's where the resonance is going to occur. The top carbon-oxygen bond, that is simply going to be a single bond, and that bond's going to be longer than the other two, which are going to be worth 1.5 of a bond. Now, the reason why that one does not have resonance is it is also bound to hydrogen, and so it cannot participate in resonance in this case. So it's just going to be the bottom two carbon-oxygen bonds, and they're going to be the same length because, remember, resonance is an average of the two drawings that you see right there. So you get 1 point for the correct Lewis structure and 1 point for indicating resonance, which is represented in this diagram here. In F, it tells you a student prepares a solution containing equal amounts, equal molar, of acetic acid and your acetate ions. Remember, just ignore Na. The pH is measured to be 4.7. The student adds 2 drops of nitric acid. Remember, nitric acid is a strong acid, and stirs the sample, observing that the pH remains 4.7. Write a balanced net ionic equation for the reaction between nitric acid and the chemical species that is responsible. So, right here, because you've got acetic acid and an acetate ion, that is a buffer, which means if you add a strong acid or a strong base, it's going to resist a change in pH. Well, since I'm adding a strong acid, that means that the acetate ion, which is a base, that's going to react with the acetate ion. So it's going to be the acetate ion reacting with H+ to produce acetic acid.